The next thing I want to examine now is to actually look at the graphs. So I want to start off by graphing just a general exponent function. I'll pick f of x is equal to 2 to the x. Now we've got our graph paper. And remember, our graph looks something like this, right? Something like that. Now we said that each one of our points, or every single one of these graphs, goes through the point 0, 1. The base graph in the form whatever to the x always goes through the point 0, 1. Oh wow, I did that really well. Holy cats. Alright. Now we established that the inverse graph is the logarithm. So the inverse graph is the logarithm. Now we learned a special way to graph inverses without even having to use a calculator. Remember how to do that? We graphed it. Remember we drew in the y equals x line? Yeah, straight lines I'm not so good at. But we drew in our y equals x line, and then we talked about what would happen if we folded this graph along that line. We did kind of an ink blot. We also talked about how all the x's and y's got switched. So if you think about folding this along the y equals x line, you're going to end up with something that looks kind of like in that shape, right? Because the opposite of this shape, a mirror reflection, would be that shape. Okay? But like we said, all the x's become y's and all the y's become x's. So this point here that's at 0, 1 will now be over here at 1, 0. So just like it went off this way to infinity, it's going to come like this. And actually, let me just do that another color. Start right here. Like that, and then come like that. So now we have a graph to the x and a graph of the inverse, log base 2 of x. Now anytime we've got a graph, I'm always going to ask, what is the domain of this function? So what is the domain of the graph? So remember, the domain is on the x-axis, so if you smush it on the x-axis, so it's obviously going to go this way forever, right? This way forever and ever. Yeah, so it's obviously going to go that way forever and ever. But what about down here? As it comes down here, is it ever going to get past that 0? The answer is no. If you remember, like this over here, this went closer and closer to 0 and went halfway through the door, I went halfway through the door, I went halfway through the door, but I never actually made it through the door. The same thing's going to go here. I'm going to get super, super, super close to 0, but I'm never actually going to get there. So the domain of this function, of this log function, is that I'm going to go at 0, but never ever actually get there, and then I can go out to infinity. Now similarly for the range, we're going to smush it on the y-axis and see where we get. Now if we smush this along the y-axis, you're going to see what's the farthest down we can go. Farthest down we can go is down to negative infinity. The farthest up we can can actually go all the way to positive infinity. So our range on the graph goes from negative infinity to positive infinity. Now, an interesting consequence of this is that to find the domain, or anything, so if we have, say we have f of x equals log base 2 of x. Well, for this thing, any value that you give me, say, looking at this graph even, if I gave you x equals negative 1, I ask you, well, what is the value of the log there? You'd say, well, there isn't one. It's not defined. Even if I asked you for the value at 0, you'd say, well, I don't get to 0 because my domain starts at 0 but doesn't actually include it. So what's important to notice is for any log, not just log base 2, but any log base b of x, you cannot take the log of a negative number or 0. Or 0. You can't take the log of a negative number, and you can't take the log of 0. So that means that given something like this, x always has to be greater than 0. So this opens up a whole new set of problems that we can give you, and we can ask you to find the domain of all kinds of stuff. So if we say find the domain of f of x is equal to log base 4 of x plus 3. F of x is equal to log base 4 of x plus 3. It doesn't matter what the base is. What matters is what this x is. So that's at x has to be greater than 0. So whatever we're taking the log of, that has to be greater than 0. Okay? So subtract 3 on both sides, and I get x is greater than negative 3. So x is greater than negative 3. So that means x starts at negative 3 and goes off to infinity. So that would be your domain. Okay? Whatever it is, whatever you're taking the log of, you can't take the log of anything that's negative or 0. So whatever you're taking the log of, that has to be strictly positive. So as you can imagine, we can get all sorts of crazy problems. So we want to find the domain of, say we had something like log base 5 of x squared plus 3x plus 2. Now this is a problem like we've had on previous homework assignments. We'll go ahead and we'll walk through this. So we want to take that, and we're going to say, well, that has to be greater than 0. Okay. Now if you remember how we did this, one of the first things we did is we had to find the zeros. So we had to say, okay, we have x squared plus 3x plus 2 is 0. So we had to factor. And we get 2 pluses, a 2 and a 1. So x plus 2 is 0. X plus 1 is 0. So x is negative 2. And x is negative 1. Then we graphed it on a number line. And we talked about how we were going to leave open and closed circles as appropriate. Are these going to be open or closed circles? I can do this, I really can. These are going to be, each of them, they're going to be open circles, right? Because we're looking for strictly greater than. We only closed the circles when we had an equal to. But here, since we're strictly greater than, we're only going with open circles. So I'm going to open my circle here, and I'm going to open my circle here. Then we go in here and we would take our hybrid method. We'd say, okay, well, we've got 1, 2, 3 sections to deal with. So I'm going to go graph y equals x squared plus 3x plus 2 on my calculator and see what it looks like. So I've got y equals x squared plus 3x plus 2. I'm going to graph it. And something's going on here. I've got 3 sections. It's kind of hard to tell. So I'm going to zoom in over here. Say OK. And now I can see what's happened because this is my 1, 2, 3. So over here on the far left, I'm going like this. Then I'm going shoop under. I got an under part and I've got 2 arms, and I don't really care beyond that. Because all I care about, right, is the greater than 0 part. We talked about how this up here represents y is greater than 0, this down here represents y is less than 0, and that represents y equals 0. So I want to say again, where am I greater than 0? Am I greater than 0 over here? Yeah, this guy's clearly in the greater than 0 part. So that means I want to include his section. This guy down here, no, because he's less than 0. So I don't include that. But over here on the right, again, he's greater than 0. So can go off to the right forever and ever if it chooses to stay on there. And now reading off my number line, I can say, okay, I'm going from negative infinity to 2, and then from negative 1 to infinity. So you see, this is really clever now, right? Because we can ask you questions over anything. This is super fun. All right. One more example, because I think this one's kind of tricky. So I wanted to find the domain of f of x is equal to log base 10 of x minus 8 squared. Now, first of all, make sure you recognize that when it says x minus 8 squared, the squared applies to the x minus 8, not to the log. It applies to the x minus 8. So we have x minus 8 squared has to be greater than 0. Now, some people will do is they'll go and they'll take the square root of both sides and they'll get this. So they'll say x has to be greater than 8. Now, unfortunately, that's only half of the problem. It's only half the problem. So really a good way to think about this is to kind of talk yourself through it and to recognize, okay, well, you know, what things do we have that are squared that are not greater than 0? I mean, because there's pretty much nothing, right? You know, anything negative, if you square it, it's going to be positive. Anything positive squared, it's going to be positive. It doesn't really matter what negative things you square, they're going to be positive. So the question is, what's the one thing that you can square that won't be strictly greater than 0? What's the one thing that you can't square that will be not, what's the one thing that you can square that will not be strictly greater than 0? Give you a chance to think about it while I write. The only thing that isn't in 0 when squared is is 0 itself, right? Because if I square 0, I get 0. I get the equal sign. And why does it do that? I get the equal sign. I don't want the equal sign because this is strictly greater than. So that means that the only thing I want to exclude from my solution, that everything in my solution works except when x minus 8 is 0. So now I can say that x minus 8 is not equal to 8. And that would be your domain. Another way, if you wanted to go ahead and graph it so that you could make set notation for it, is to say, well, here's my number line, here's 8. I don't include 8, but I do include everything else. Come on now. I do include everything else. So I go from negative infinity to 8, and then from 8 to positive infinity. It's kind of cool, though, because if you want to graph it, you can. Here, graph it. So I'm going to graph log, and it's base 10, but we'll talk about that in a second. Is that really annoying? Can you hear that? Log base x, 8 minus x, blah, x minus 8 squared. Now if I go and I actually graph this, I have to go back to my regular picture. Zoom, standard, and you see something funky's happening right there? So what I'm going to do is I'm going to go look at the table, and as I scroll down, I'm going to see that at x equals 8, I actually get an error. So that's what we mean, remember, by the domain, is that something that you can't say. So we can't take the log of 0. The only time we would get that is if x equals 8. So you can see the calculator is going to confirm what you're doing by hand.